Imagine this for a moment. You are floating far beyond Earth, past the moon, past the last icy planets. You keep going deeper into the dark. Then suddenly, without seeing a wall, without hitting anything solid, you reach a boundary, a quiet edge, a place where the influence of our sun finally weakens and something else begins. Scientists believe this invisible boundary sits roughly 1.5 light years away from us, and most people have never heard of it. This idea sounds strange, almost unreal. How can there be a wall in space when space is supposed to be empty? No bricks, no glass, no metal, just darkness. Yet our solar system is not an open field. It lives inside a kind of bubble, a protective zone created by the sun itself. And that bubble has a limit. To understand this, let us step back and keep it simple. The sun is not just a bright ball of fire lighting up our days. It constantly throws out energy in all directions. A steady flow of charged particles moves outward like a cosmic wind. This flow pushes against the material floating between stars. Over the billions of years, it has carved out a space around our solar system. Think of it like a boat moving through water. The water parts around the boat, creating a clear region before it closes again behind it. Our solar system rides inside this clear region. Scientists call it a kind of shield. It blocks or weakens much of the dangerous radiation coming from deep space. Without it, life on Earth might never have survived. Our planet would be far more exposed to harsh cosmic forces. Now here is where it gets fascinating. At some point, this shield does not stretch forever. The sun's influence slows down. The pressure from interstellar space pushes back. The result is a boundary, not sharp like a wall you can touch, but real enough to measure. Probes were sent decades ago are slowly reaching right now. One of them, Voyager 1, was launched in the 1970s. It is still traveling, still sending whispers back to Earth. As it moves farther away, it detects changes. Fewer particles from the sun, more particles from deep space. That shift tells us it is crossing into a new region, a place where the solar system ends and the wider galaxy truly begins. This invisible boundary matters more than it seems. It marks the edge of our cosmic neighborhood. Everything we have ever known, every planet, every comet, every human story sits safely inside it. Beyond that edge lies a different environment, one we barely understand. 2000 onward, and this raises a quiet but powerful question. If our solar system has a boundary, what about others? How many such bubbles fill our galaxy? How do they interact? And what happens when stars move and these invisible borders collide? This is not just a distant science idea. It is part of our story. A reminder that even on the largest scales, we live inside limits, protected for now by forces we did not create. In the next part, we'll explore what this invisible wall is really made of and why it behaves more like a living border than a fixed line in space. 2000 wall. So what is this invisible wall actually made of? If you traveled there, you would not see a line glowing in space. In 2000 onward, there would be no sudden crash or stop. Instead, the change would be slow and subtle, like walking into a quiet fog without noticing the first step. Space there is filled with tiny particles, fields of energy, and constant motion. The sun sends out its energy non-stop. This stream moves incredibly fast, far faster than anything we can build. For a long time, it dominates the space around us. But the farther it travels, the weaker it becomes. Imagine blowing air into a large room. Near your mouth, the air is strong. Across the room, it fades. Eventually, it blends with the air already there. Space works in a similar way. Beyond our solar system lies the space between stars. It is not empty. It contains scattered particles, ancient dust, and energy from exploding stars. This material presses inward. When the outward push from the sun meets the inward push from interstellar space, a boundary forms, not solid, not still. It moves this and breathes over time. What makes this boundary so is that it changes. When the sun becomes more active, the boundary expands. When the sun comes down, it shrinks. The wall can move closer or farther by billions of kilometers. That means the size of solar bubble is not fixed. It is shaped by the mood of our star. This is why the Voyagers are so important. They act like explorers dipping their hands into unknown water. As they cross different regions, their instruments notice shifts. The signals tell us when the sun's influence weakens and when the galaxy begins to take over. It is the first time in human history we have touched the edge of our home system. There is something deeply humbling about this. For centuries, 2000 onward, humans believed the solar system was everything. Then we learned about other stars, then galaxies. Now we are learning that even our solar system is wrapped inside a fragile, changing shell. Think about Earth for a moment. Our planet has an atmosphere that protects us from space. Our solar system has a similar kind of protection, just on a much larger scale. In both cases, life depends on staying inside that shield. Without it, conditions become far harsher. This invisible wall also teaches us that space is not static, it is active. It pushes back, it responds. The universe is not just a backdrop. It interacts with us even if we cannot feel it. In the next part, where the military 2000 on, we'll look at why this boundary could shape the future of space travel and what it means for any civilization trying to leave its home star system. Now, let us think about what this invisible boundary means for the future, not just for scientists, but for humanity as a whole for a long time. Space travel has meant moving between planets, the moon, Mars, maybe the outer worlds one day. All of that still happens well inside the sun's protective bubble. Crossing this boundary is something very different. Once a spacecraft moves beyond it, the rules begin to change. The space becomes more intense. Radiation levels rise. The particles are faster and more unpredictable. It is not instantly deadly, but it is far less friendly. Any future mission that aims to travel to another star will have to face this region head-on. This makes the invisible wall a kind of first test. Before we can dream of reaching nearby stars, we have to understand how to survive outside our solar shelter. How do we protect machines per thousand onward? How do we protect human bodies? How do we communicate across such vast distances when signals take years to travel back and forth? There is also a deeper idea here. This boundary marks the limit of the sun's authority. Inside it, the sun shapes the environment. Outside it, 2000 onward, the galaxy takes control. It is like leaving your hometown and stepping into a foreign land where the laws are different. Scientists believe that cosmic rays from deep space may affect planets over long periods of time. Some even think changes in these rays could influence climate or life in subtle ways. Our solar bubble may act like a filter, softening those effects before they reach Earth. If that is true, then this invisible wall has quietly helped life survive for millions of years. There is also a poetic side to all this. Every radio signal we have ever sent, every message meant for the stars is still traveling outward. But it has not gone very far yet on a cosmic scale. Many of those signals are still inside this boundary, bouncing around in our local neighborhood. So in a way, our presence in the universe is still wrapped in the sun's influence. We are newborns on a galactic timeline. It can turn something out onward. Just beginning to touch the edge of something much larger. This boundary also reminds us that exploration is not just about distance. It is about understanding environment. The universe is layered. Each layer has its own challenges. Each one demands patience, curiosity, and respect. In the next part, we will zoom out even further and explore how our solar system's invisible wall fits into the larger structure of the galaxy itself. When we zoom out and look at the galaxy as a whole, this invisible wall starts to feel less like a strange exception and more like a common rule. Our galaxy is filled with stars like the sun. Each one sends out its own energy, carving a personal space around itself. That means that the Milky Way is likely packed with countless and invisible bubbles overlapping, stretching and drifting through the dark. As stars move around the galaxy, these bubbles move with them. Sometimes they grow, sometimes they shrink. In rare cases, 2000 onward, they may even brush against each other. When that happens, the boundaries can distort like soap bubbles pressed together. This tells us the galaxy is not just a collection of stars, but a living system of interacting regions. Our solar system is also not standing still. It is traveling through the Milky Way at an incredible speed. As it moves, it passes through areas with different densities of matter. This changes the pressure on our solar bubble. Long ago, our invisible wall may have been larger or smaller than it is today. In the distant future, it will change again. This movement could have consequences. If our solar system enters a denser region of space, the boundary could compress. Might allow more high-energy particles to reach the inner planets. Over very long time scales, this could affect atmospheres, climates, 2000 onward, or even the development of life. These changes would be slow, so measured in thousands or millions of years. But they remind us that Earth's safety is not guaranteed forever. There is also an emotional side to this idea. Everything humanity has ever built exists inside this soft, shifting border. Our myths, our history, our science, all live within the reach of one star. Beyond it lies a realm shaped by countless others. This does not make us small in a meaningless way. It gives us context. It shows that our home is part of something vast and connected. Understanding where our influence ends helps us appreciate where it begins. In the final part, over 2000 onward, we will bring everything together and reflect on what this invisible wall teaches us about our place in the universe and where our future journeys might lead. When you step back and look at the full picture, this invisible 1.5 light-year wall feels less like a limit and more like a quiet teacher. It shows us that even space has neighborhoods, even the universe has borders, not drawn with lines, but shaped by energy, motion, and time. Partly for all of human history, we believed the sky was the boundary. Then we learned it was just the beginning. Now, we know that even our solar system has an edge, a soft boundary, where the sun's reach slowly fades and the galaxy takes over. Everything familiar exists on one side of that line. Everything unknown begins just beyond it. What makes this idea powerful is not fear, but perspective. This wall has protected Earth without asking for credit. It has reduced the harshness of deep space and helped create a calmer zone where life could grow. In a way, 2000 onward, it is part of the reason we are here at all. At the same time, it reminds us that exploration will not always be gentle. 2000 onward, if humanity ever becomes a star-traveling species, this boundary will be our first true goodbye to home. Crossing it will mean leaving the comfort of the sun's influence and entering a space shaped by the wider galaxy. There is something beautiful about that moment. A small probe built by human hands, drifting past an invisible edge that took billions of years to form. No explosion, no sound. Just a quiet transition into a larger story. The universe does not rush us. It waits. Our solar system's wall has been there long before humans existed, and it will remain long after we are gone. But now, for the first time, we are aware of it. And awareness changes everything.